And now we are going to dive into the first panel discussion. The topic is Gaussian splatting and how to use it in technology and creative industry. So we're going to dive into one of these most talked about techniques right now in the field of 3D capture and rendering. And it is changing how we think about realism, speed, and production workflows. So we're going to have exciting guests. This panel will be moderated by no one else than Michal Gula. Let's give it up for Michal.
Thank you.
Enjoy.
Thank you. Malo stolčík. We need one more chair. Thank you. As you certainly know, guys, we were communicating this that the 3D Gaussian splatting should be a main topic of this event. So it's always interesting not to just hear the advantages or the features from one point of view. I love when there is a discussion with different point of views. So even this panel discussion, we were trying to set in a way where people with skill and knowledge about 3D Gaussian splatting are coming from different kind of industries, so that we can discuss and see how each industry is working with it. So with that being said, let me introduce you here, Tomas Barnas from Overhead 4D. Matej Kosovsky from Pixelmundo, part of Sony. Tomáš Misura, Epic and RealityScan. And Michael Rubloff from Radiance Fields. Guys, I already said that you are coming from different fields, so I hope you will have different opinions on the 3D Gaussian splatting. So my very first intro question would be, what does it mean for you, especially within what you are doing? Maybe we can start with Michael.
Yeah, so for me, this consumes my entire life, essentially. You know, every single moment of my day revolves around either Gaussian splatting or any of the Radiance Field representations, and really profiling and cataloging where they're being used out in the world, both on the actual production side and into the research world as well.
How deep are you going with the research? Because you are famous for the saying that there is every 5 minutes there is a new paper regarding the 3D Gaussian splatting, right?
Yeah, no, it's definitely gotten progressively more difficult to keep track of the individual papers that are coming out, because the frequency is still kept up in terms of the amount of research interest, and on top of that now there's even the actual shipping of products out into the world. So it's been really fun to actually follow along with some of the developments on the research side.
Tomáš, we already mentioned that you are coming from Epic and RealityScan. For those who might not know it, it was like 2 years ago when it got renamed from Reality Capture.
Yeah.
So for those who has been in a photogrammetry long, that's the company, okay? And this guy is from it.
Yeah, we had a website called Capturing Reality. The product was Reality Capture, and we renamed it to RealityScan, so it's more streamlined.
So if you are mixed, it's okay. You're supposed to.
No worries. Me too.
So what does it mean for you, the 3D Gaussian splatting?
Yeah, for me, I have a little bit of déjà vu, because I have been in this field for quite some time, and even photogrammetry has been kind of a second cousin next to laser scanning, and nobody took it seriously for even metrology purposes. And it took a while to really build something around photogrammetry. And for me, it's really important that Gaussian splatting is now kind of the new technology, or even any form of radiance fields, in my opinion, are kind of popping up. And what we are trying to do is to support this and also help with democratization. So as you might know, RealityScan is one of the state-of-the-art structure from motion engines, which is really important to have nailed. For any kind of capturing purposes, it might go wrong. So you really need to have really good registration done. And afterwards, well, what we are trying to do is to open this to any company or tool where you can create Gaussian splatting. You know, there are post-shot, licht-field, you name it. You can even wipe code your own right now. So opening this to everybody is really important to support the democratization, in my opinion.
Tomas, the second Tomas Barnas, you already had a great speech, great presentation. Congrats again to that. It's a huge project and it was a great presentation. You already mentioned that you look at the 3D Gaussian splatting not as something that would be sold directly, but as a part of the development. So how do you feel? Because I remember these talks between us a long time ago, because I like to call him a demigod of photogrammetry, because he has been doing photogrammetry before it was cool. So I like to ask you, like, how do you feel? Are you going to switch from photogrammetry, or what place does 3D Gaussian splatting has in your business?
For me, that's natural development. So something like Tomas said, like there are always times when something new is popping up, like we have AI, we have other things which are then suddenly kind of like hype, or people are trying to check it and be involved and see how it goes. But for me, this is a part of development and part of every project and, as I said, like development of the future, because you can't just stay with the technologies you are using for 10 years. If there is something 10 years, there must come something what is new. And this is for me Gaussian splatting. We just actually used exactly the same pipelines. There came just suddenly another processing tool which help us to create another kind of data. We have to involve our processes to figure out how to implement them, but it's not about like thinking differently or looking at it like something totally new. It's more a development of something what I would say like all of us have used, and we just need to be open to bring it into our pipelines and then try to gain from it the good or the good thing for you. It doesn't have to look like entirely good, like what I just said in my presentation. It's more about, for me, about using Gaussian splats there where we need them. So we still combine everything. We do laser scanning, we do photogrammetry, but we never could have such a good backdrop scenes without Gaussian splats. And this is just something what is helping us to create a unique experience for the same amount of work, or even less, but enhanced and better.
Perfect. Matej, you're coming from Pixelmundo, from basically a filming industry. You specialize on special effects. It's interesting that we are speaking about the same technology and everybody is using, or there are many various ways how to use the 3D Gaussian splatting. So what does it mean for you in your industry?
Well, I have to agree with what Tomáš said just now, that it removes a lot of barriers from the technical aspects that photogrammetry had before, and this broadens up the use case. So you can utilize it on film, you can utilize it in games the same way, but before we had to do a lot of the technical stuff behind, so games had to be optimized, but now it's like a level playing field, and it's very simple and easy for people to understand because it looks so photoreal. So even if you are delivering it to different clients, it's very easy to explain to them that this is the result that we can achieve now, and it doesn't matter how it's done. It's just, this is the new frontier that is possible.
Perfect. Before we were preparing for this panel discussion, we had a talk with Tomáš Misura, and he has a question actually for you guys. Okay, so get ready with your phones, and it's your time to ask the question.
Yeah. Can we put it here? Yeah. Have you used Gaussian splatting in your work? So this is like a warm-up question. So how you feel about this? I think this is a really important topic. People are talking about it, full LinkedIn, you know, there are so many posts about it, but have you actually tried it out? Have you got your hands dirty?
We will wait for a few seconds more, but there is already more than 70 responses. You really want to win something, apparently. And it's almost, yeah, it's over 40%, 45, 44% of people that have already experimented with the Gaussian splatting, which is incredible because you can always meet even people from the industry that have like zero idea what's 3D Gaussian splatting. Then I'm always saying, like, guys, you should pay the attention. Typical bias that I'm confronted with is that many people think that it's a hype. It's just the hype, like it was with the metaverse or like it was with NFTs or whatever. And I like to point out that here are people and companies that are quite heavy on in the industry, and they are seriously thinking about 3D Gaussian splatting and working with that. So, as first, the Radiance Fields from Michael, he's doing a lot of research. So, could you just confirm, like, how big companies are taking seriously the 3D Gaussian splatting?
Yeah, what's really nice to see is how it's generalizing across some of the largest industries in the world. And this includes, you know, AEC and geospatial with companies like Esri and Bentley systems that are adding support for Gaussian splatting. And we're also seeing a lot of these governing bodies as well, such as like the Kronos Group and the Alliance of OpenUSD, for instance, also creating these standards for Gaussian splatting. But when we take a look at other industries too, you know, there's definitely a very large interest in the hospitality and real estate world, where we have companies like Zillow that are now have added Gaussian splatting support through a platform called SkyTour. There's also on the opposite side, there's the CoStar Group, who owns apartments.com and homes.com. They also own Matterport, and they actually have a product now called Matterport 3D Exterior. And recently, I think just like a week or two ago, they announced that this summer it's actually going to be shipped to about 1,700 different suburbs in Australia as just one segment. So it's starting to really make its way into that industry too. But definitely another really big application has been the media and entertainment world too, where for virtual production, you know, location scouting, this has been a very powerful tool for them, where they can start to actually visualize and preview their productions in a much more cost-efficient way. But we've also seen it in the visual effects pipelines too, where there are examples that I'll show a little bit later today from the Superman movie last year, where every single shot of Superman's parents in that movie is not in fact 2D. It actually is complete dynamic Gaussian splatting. But we've seen examples from Sinners as well, for if you were wondering how they were actually creating a twin of Michael B. Jordan, they actually were creating a Gaussian splatting reconstruction of him and using that to actually supplant from the performance. And other examples are Dune Prophecy has also used Gaussian splatting. And one other thing I want to highlight about the media and entertainment world is that it has a very long lead time associated with it. And so for the example from Superman, this was completed, you know, over 2 years ago, but we only saw it last July. And so there's a lot more works that are taking place right now that just have not been released yet, but hopefully by the end of this year, there'll be a lot more examples for us.
It's great to hear your opinion, because you are in touch with a lot of these companies, so you can actually have it from the first hand whether they are working or not working on 3D Gaussian splatting. So thank you for that. Tomas, you are coming from basically a behemoth of photogrammetry softwares. Like I think that many of people from our audience were or are using the reality capture now, RealityScan.
And we are happy.
So I'm just wondering how such a big company as Epic is touching this point, because it might seem that it's actually in a conflict, right, with so far what has been done with the RealityScan. So how do you tackle this?
Well, it's one of the modalities that you can use for storytelling, and I think it kind of narrows the gap between if you want to use a picture, you want to use a video, you want to use HDRI, you want to use 3D textured model done with a really precise techniques like the talk that was before with photometric stereo. You can do even, obviously, Gaussian splats. You can combine it with Radiance Fields. And, you know, you can name it. You can try and use anything which suits your needs. I've seen a lot of utilizations, also thanks to Michael, that is keeping me up with all of this. And it's just crazy. Like, you can really utilize everything. Where I'm really glad is also most of the time everything ends in Unreal Engine. So that is also something that is amazing. And what I can also say is, obviously, we are also working on solutions to improve this pipeline. And yes, it's one of the important things that we need to tackle, just to open this, as I said, and democratize this.
So I'm just guessing that Epic is not going like all in with the Gaussian splatting.
No, not really. As I said, one of the modalities, and it's not like we are going full throttle on that, but yeah, options are something that needs to happen.
We already saw in the survey that more than 40% of people have actually tried 3D Gaussian splatting. So maybe you can ask your second question.
Oh yeah, let's do that. This one will be a little bit more hands-on. Can we? Yeah. So what do you use it for? This is kind of open-ended, be creative. Sexy body was one of the good answers I've seen in the last poll. But, you know, anything.
Try not to repeat the joke. Stop motion, VFX.
While we are waiting, I just wanted to mention one thing, because we said multiple times that if you follow Michael, or we saw it from Michael, so for those of you who are not really following it, that's not a promotion, that's just like Michael is really giving a lot of information and a lot of papers and all the stuff about Gaussian splats online. So if you're following him, you really will not miss the best news. So just heads up to this, because I'm trying to be informed, I'm trying to follow it myself, but yeah, it's great to see always your stuff.
He also has RSS feed, very important.
Yeah, no, as more industries have started to add support and there's more examples, it's definitely become harder to follow the totality of its applications. But yeah, if you're interested to follow along, definitely would suggest it. But anyways, do you want?
For the record, this is not a paid promotion of Michael. Okay, so we have more than 60 answers. So basically, it seems like it's for VFX, cultural heritage, virtual tours, visualization, environment, visualizing existing buildings. Okay, only scans. Is it something like OnlyFans, or is it very different? Not sure. And generally 3D. Great, thank you for that. Tomas, we have a question. What are the main limitations of Gaussian splatting in general?
The main limitations, that's still a point that you need to kind of decide what you want to do with those data. That means they're good in or from the views you are capturing. So you cannot expect something that you capture it from certain angle, and then suddenly you want to have like top-down view when you are capturing it from front side or sides, that you will get great views of Gaussians. So I would say like a negative part or limitations is that you need to think what you are doing and you need to know what you are going to achieve.
Matej, when was the first time that you realized within the Pixelmundo that we have to pay attention to 3D Gaussian splatting and tried?
I think as soon as it came out, we always try to stay on top of the latest technologies. And about 3 years ago, we started with nerves and then quickly shifted fully to Gaussian splatting. And I think that's the same for everyone in the industry. In the poll, the biggest use case was VFX, and I'm not surprised, because usually a lot of demand is in this very hard to get industry. So similar to F1, you develop a lot of technology in that high end, and then you distill it down to consumers. And I think that's same thing happening with Gaussian splatting, that you develop it with high budget and high quality and demanding clients, and then it's broadening up. So all the big tech industries now are having their own take on it, and that's something very powerful about Gaussians, is that not one company came up with it and holds the rights for it, but it's open source, so you can see a lot of these new integrations and developments around, so anyone can use it and interpret it for their industry. So it's very interesting to see how it's growing.
I like to always say that the 3D Gaussian splatting was not meant to be for the accuracy, for the very, very high geometry precision and everything else, but we still can see a lot of papers that are trying to achieve this. So Michael, this is the question for you, like, where do you see this going? Am I going to be wrong very soon with my expectations that 3D Gaussian splatting will not be accurate enough to measure?
Yeah, so I think that if I had to make a prediction, I think the three things that will really take a bit of a leap this year will be, one, relighting, I think, is going to get a lot stronger and more capable from Gaussian splatting. You know, I think that also on the measurement side, too, we're going to see quite a lot of examples, too, from that world. And yeah, I think that there's also a lot of really great research works right now. So some of them would be like mesh splatting, or radiance meshes is another paper, and there's another one I think that's called like from like spokes to blobs, I think is what it's called, and that is also another really promising direction for the world of meshing from splats. So I think there's going to be a lot of momentum over the second half of this year for those three challenges, and will potentially change how we perceive or utilize the representation.
I would like to add to that question, just because this is very often asked, and also I would call it like kind of a bias from the beginning, that when you see Gaussian splats and you are used to have like precise laser scans, you are trying to divide these worlds. Now we have already solutions which are combining LiDAR and creating Gaussian splats, which are making them accurate as LiDAR is, let's say. But even before that was happening, we tried to play with it in a way that we've created the Gaussian splats, but in parallel we created a laser scan with terrestrial laser scanner. And we were manually overlapping these things and matching them, overlapping them. That means if you find your way, or if you think about it, that there can be a layer which is helpful, then you can use it. And that's always my point to Gaussian splats, that you should think about layering. That's a layer. You have a layer of point cloud, you have a layer of photogrammetry with textures, and then you have a layer of Gaussian splats. And then you combine them and use it for the benefits. So yeah, if you want to measure, then you will measure on the terrestrial laser, which is just one layer below. So in that case, for me, this is a kind of a wrong question, or just like wrong thinking, because you can just rethink it, and then you get the resolution you want or the accuracy you want.
Tomas, we have a very direct question to you. Will Gaussian splatting be possible inside RealityScan?
Well,
I cannot say.
I can say that there are kind of two sides of that. One is the training, then actually more of that. There is training, optimization, rendering, editing, you name it. And yes, definitely something along the lines will be possible. Last year, we published something that might have been like an unimportant release, where we introduced gRPC plugin, which is opening also doors to things like MCP servers and all of that. We didn't really talk about it yet, but you can do a lot of things with that, thanks to other things in AI, because you have full toolset with CLI, you have full toolset with gRPC protocol, polling, all of that. So yes, for like even automated pipelines, you can do it even right now. You just also need to help yourself with some GitHub repo, which is on the research side, but for really easy user experience directly inside RealityScan, I can just say that we are working on that.
Great. Matej, I know that you have been using laser scanning and photogrammetry mostly for like a preparation of the scenes, right? Have you been using this technology also like in a direct footage of the movies or?
For Gaussian splatting or
No.
photogrammetry?
The first question is about laser scanning and photogrammetry, because the follow-up question will be like if the Gaussian splatting is actually being used also within the films, or again just for some preparations.
Yeah, so there are multiple use cases that we have for this technology. LiDAR gives you the accuracy, so that's something that we use a lot as a supporting data set. But it doesn't have the texture fidelity or the creative freedom that the movie industry often requires. So there needs to be some kind of artistic addition on top of that after the scan is created to make it into the final picture. With Gaussians, we can use it directly as an output, so you can put it directly to the final picture because it is photoreal, or it can be close to it. But because of the current limitations about the flexibility, like relighting and other issues, which are now being solved slowly, actually quite quickly, I would say, it's going to be more and more involved in the pipeline and the workflows for everyone in visualization. And in terms of like what part of it is, if it's at the beginning for previs or planning or its final picture, I would say it's across the board. Starting with planning is the easiest, but because you don't have to use it at the end. But if you plan well for a mission, for a capture mission, you can use that data set in the final picture as well.
Mm-hmm. More than 40% said that they already tried, which automatically means that the rest have not. Either because they didn't have time for it, or they didn't know how, or they just found out about the 3D Gaussian splatting. So maybe for those people, could you, Michael, just like in the most simple way explain what it actually is 3D Gaussian splatting?
Sure. Like so basically, Gaussian splatting is it's not the most approachable word or name for a technology, but I promise it actually is quite simple to utilize. Where what's really nice about Gaussian splatting is that you can create the data necessary for it from any 2D camera. So anything that's capable of taking a still image can create data necessary for it. So that can range all the way from a phone to a film camera to an IMAX camera. All this can actually reconstruct into 3D. And basically, we have these three-dimensional ellipsoids, kind of like almost like an American football shape, and we are going to essentially splat them or throw them against a 2D canvas. And instead of it looking just like a bunch of random paint splattering, it actually will represent a pretty lifelike representation of what has been captured. And some of the information that, you know, if you're trying Gaussian splatting and say it's not coming out very well, two of the things that Gaussian splatting really loves is it will reconstruct what it sees. And so if you are giving it very sharp and deep depth of field images, that gives it a whole lot more information to actually go and reconstruct the world. And so an example could be something like using a wider focal length lens, because you're able to actually pull in more information per frame, and you're getting a shorter hyperfocal distance too, so you can keep things in focus and make it nice and sharp. And the second thing that Gaussian splatting really loves is having these like multi-view perspectives and parallax. And so being able to actually feed it opposing, I guess, images, and being able to really showcase the full 3D scene, or the 360 of a given space. But to this same nature, you know, there are cameras like 360 cameras that make this really easy to go and actually just pull in a lot more information about the physical world in the same amount of time. But I would say, you know, just kind of really, you know, if you start to give it sharp images and multi-view perspectives, that will really help your captures level up quickly.
Mm-hmm. We have pretty much upvoted question here, so I am going to ask, not sure right now to whom it's going to be, but you pick, guys. Have any of you been able to get a good reverse models and assets, texture, maps, or creating anything else from a 3D Gaussian splatting yet?
So it's something what I have just mentioned previously, and this is for me the point when you are thinking about this technology maybe slightly wrong, because creating Gaussian splats, it's not about creating textures. So that's generally like a first point which I would mention, because we are speaking about colored splats, points. We are not speaking about painted texture, which is there for photogrammetry. So actually, it's very hard to answer, because I would just rethink it, like use it as a layer, as something what you put in the background or next to it, or overlap it with the textured model if you want, but you are not able to extract a model with texture from the Gaussian splat.
There is maybe one thing that I would say, and that is what I see across the industry is that people are generating meshes even from Gaussian splats, but for very different purposes that you would expect. That they need to have collisions, for instance. So, and even for measurements, right? You don't really measure on that point cloud or even splats. You can measure, though, on the mesh, which is below that as a layer. And obviously for collisions, you need to have some kind of primitive. So that is also another use case that is pretty common now.
That's a really good point, but at the same time, if you need it for collisions, you don't need very precise geometry.
Yes,
right?
They are two different kinds of meshes that you would need.
So there is no need for a hunt for like very accurate output from the 3D Gaussian splatting into 3D meshes.
Even for optimization purposes, you don't really want to put there, 5 billion polygons below that Gaussian splat. That would just not cut it.
I would like also to dig deeper into the thinking of within the epic, because like first or another bias that I like to mention always is that people from the very beginning were saying that you cannot use 3D Gaussian splatting within the gaming engines, right? Because you are used to work with 3D meshes or 3D models or primitives and so on, but you tackled it pretty easily, right? So you just adjusted your workflows within the Unreal Engine.
I mean, yes, I must say, this is all hacking. It's not like a native support. You need to kind of, twist it. It's not necessarily the real representation how it should look like, but what needs to be real. In film, for instance, nothing is real, and who will get it that it's not? Does it need to be real? Well, these are all questions. For games, though, it's a little bit different. People are used to do certain workflows. Even though you can now use Gaussian splats through web, it's still not, that optimized to really run the whole AAA game this way. It's just lacking a lot of stuff right now. But it's in the early stages, and I think it's something that I'm really looking forward to see how this will develop.
Mm. Matej, are you using also dynamic Gaussian splatting within VFX, or you're just focusing on 3D Gaussian splatting, not 4D?
There is definitely a use case for it. Different clients might demand that, but I cannot confirm or deny.
Unfair enough for our audience. Is there something right now from the feature point of view of 3D Gaussian splatting that you need and you are missing right now for your purposes?
The flexibility and the workflow adaptation. So the constraints that we have, or I think most of the creative industries have, is that we have existing workflows that we work with, and you have tools that we work with, such as RealityScan, for example. And if you are bringing in new technology, it must work with the rest of the system, because you cannot just break the entire pipeline and start from scratch. So adapting it in steps or making a separate unit that is a part of the process is currently the way to go. But if you successfully implement it fully into the pipeline, that would be something that would help a lot. So I hope that you maybe work weekends as well.
All day long.
Very good. There is the question that we can touch upon as well.
Which one you like?
The top one.
The top one. Can 3D.js be as precise as point clouds and meshes for measuring things on the models, or is it only for presentation purposes?
So I have a question back for that one. The reason why you want to use 3D.js or Gaussians in general, I think, is you want to solve an existing problem. And my question is, do you have a measuring problem with existing technologies that you are using? because the reason why everyone jumped on it in visualization and previs is because getting things look realistic is very expensive, and Gaussians gets you there 80–90% very quickly. So that was the clear improvement, but maybe you don't need to use it for everything, right? Like if you have an existing method that you're using to get your clients the data that they need for, let's say, measuring, there is no need for you to adapt Gaussians for that specific use case.
With that vice versa question you could just do the mic drop, because that was exactly the right response to that. Tomas, you know that you have always been trying to try things first and do things that other people think are impossible. And I like to say that we ask people that think that something is impossible to move away for the people that are already doing this. And while people were saying that 3D Gaussian splatting cannot be used in gaming engines and in VR headsets, we did the project of us that we already used it within the VR.
Yeah, exactly. That was shortly after some of the first papers were released, and luckily we had a currently project for VR, but streamed VR. So that was different to my presentation, where like with headset integrated VR, we still can't use properly the Gaussian splats because they need more processing power. But once you need to share something, then you are able to bring it anywhere so far. So I would just say, like, yes, exactly. Just think about it, like what and which part of these you can use and use it as your benefit.
Mm-hmm. Michael, this has something to do with the question about from the audience, how it will affect the inspection of critical infrastructure. I would like to add to that because last year with the TED we have seen the AI inspection on concrete, on the bridges. It was on a photogrammetry model. Does this something somehow differ? Do you see in those papers some approaches to this?
In terms of making it like as precise or being able to see like individual cracks or
yeah, and ideally somehow automatically to identify them.
Yeah, no, I think that is very much likely to happen this year, actually, is that, we've seen a lot of semantic pairing with, say, like any of the Radiance Field representations where you can start to ask questions to the different systems or have it actually do with the auto segmentation. I think XGrids has like a demonstration of some of this in like real estate and construction as well, where we start to understand a given space or what's been captured. And I also similarly believe that the actual capture path will also begin to be automated too, whether you are just feeding it multiple cameras walking through a space and then just reconstructing that, or what I've also started to see too is people will start to just realign in post and then use it almost like a digital flip book to go and actually see a space's progression over time to do either maintenance or asset monitoring. But I think it's very, very likely that will happen.
Thank you. Tomas, this is a question for you, and I'm sure you won't be able to respond to this, so I'm going to ask you this. From the capturing point of view, do the same rules apply for capturing raw data for 3D Gaussian splatting as they do for the photogrammetry?
Yes and no. Well, as you get mature enough when capturing any assets, you know which assets to not capture. So that would be the kind of a difference where in a normal mindset, people would be like, I'm not even going to try, or just I don't have time for this. While with this technique, you can just create a really fast previews using the same methods, but even on surfaces and materials that you wouldn't even expect that they would work. And kind of that is my angle here.
Mm-hmm.
I can add to that a little bit. The main difference, there is a slight difference. Most of the method is the same. The only thing is, I would say, more. So because it's view dependent and you cannot go back and paint the textures or fix the model, you need to make sure that you got all the angles. So get more, I would say. That is the main difference for us, at least so far.
Okay, and we can end this with Tomáš. And Jeffrey is asking, now that we have 3D Gaussian splatting, why should anyone use triangles and textures and even worse, all the PBR crap anymore?
Yeah, I think I would just repeat what I just said, that you need to choose. So it's not always about one or the other, because for me, Gaussian splats are still not fully replacing, and maybe they will never fully replace like the other technologies, as also Matej mentioned, that adjustments, color painting of the textures and everything. There are still things which you can do better with the texture models, not yet with Gaussians. Whether it's completely replacing later, maybe yes, maybe no, we'll see. But if yes, then it's again just an involvement, and we will kind of like leave the previous technology and just continue the same way in maybe the same softwares, just the result will look different.
Perfect. Thank you so much, guys. If you are interested in asking some more questions to these guys, feel free to reach out to them. They are kind of nice guys to talk to. So thank you again, guys. Matej Kosovsky, Tomas Barnas, Tomáš Misura, and Michael Rubloff. Thank you, guys.
Thank you so much, everyone, for a really cool discussion.